These are the numbers I came by. Somebody told me, well, I did the integral and got 3.2. Well, that's totally plausible, okay? You know, if the, but because of this denominator, the density is going to climb more slowly. No, actually, no, forget it. I don't even want to say that. I don't think it's true. Okay, so we're going to go ahead and do the integral. Now, this is what I get from the corners and the midpoint, right? And you said the integral is 3.20. I can live with that, maybe. Okay, let's go ahead and do it. So we do this integral with respect to z, and then we'll do the integral with respect to y. Doesn't matter which we do first. One might be a little easier. And that goes from 3 to 6, right? And then we go from 2 to 4 with respect to x. And now we're integrating something I got to write kind of small, but we know what it is. 6 minus x plus z over x plus y. Okay? Okay, well, first integrating with respect to x, we're going to get 6x minus x squared over 2 plus z times the natural log of the absolute value of x plus y. Right? Because, of course, treating y as a constant, the derivative of this is 1 over x plus y. And that's, of course, between x equals 2 and x equals 4.
Why would the y be within the natural log?
Part of the denominator. If you did the integral of 1 over x plus 3, you would get the natural log of the absolute value of x plus 3.
Okay.
Okay?
Let's do that part of it.
So you would want to go back and think about that. Make sure you lock that in. Because there are many things from first year calculus you just kind of got to lock in, right? It's this course where you really learn second semester and much of first semester calculus, okay? It really brings everything together. And that was my experience. Now, if you're smart enough, smarter than I am, which most people are, you locked it in when you took the course. Okay, that's ideal. It's also kind of rare. Okay? Usually don't learn a course until you've used it in the subsequent course or in some other way, used it, brought it out of memory, gone back to the techniques, thought about what it all means. And I'm trying to point out those things like the average value of a function and stuff, okay? And that's very straightforward. I'll let you puzzle over it, okay? So, now check my arithmetic, because I tend to screw it up, but 4 minus 2 is 2, so 6 times 2 is 12. So we're going to get a 12 out of that. X squared is going to go from 4 to 16, and that's a difference of 12. Dividing by 2 is a difference of 6. Okay? And then we have z times the natural log of 4 plus y minus the natural log of 2 plus y. Well, that's the natural log of the absolute value of 4 plus y over 2 plus y. Now we're probably going to break that apart into a difference of 2 natural logs when we integrate it, because it's simpler than trying to worry about that rational function. Could be done either way. But now we have this, and we integrate with respect to y and z. Well, very easy. With respect to y, we get, well, 12 minus 6 is 6, so we get 6y plus, I'm going to skip a step at z times the integral, well, the antiderivative of the natural log of 4 plus y, right? Now, how do you integrate a natural log? You use an integration by parts with u equals the natural log and du equals d whatever your variable is, okay? So let's just digress a minute. I'm just going to do that off camera. Just a straightforward trick, and I hope I mentioned the right trick. I'll try it, and if it doesn't work, I'll adapt it. But that's pretty much what you do.